Hello guys, it's time to look at another classic LeetCode problem, count primes. Here is the description. Given an integer n, return a number of prime numbers that are strictly less than n. Alright, to recap, prime numbers should only be divisible by its number itself and 1. Okay, for example, if you have a 10 as an input, and we're gonna have 4 to be returned, because there are 4 prime numbers, including 2, 3, 5, and 7. Also, there are some edge cases, like if n is equal either 0 or 1, and we're gonna have 0 as our output. Okay. Now let's dive right into the code. Here, we're gonna have a if statement, and the condition are gonna check to see to take off our edge cases mentioned earlier, and if the num is less than 2, we're gonna just simply return 0. Otherwise, we're gonna create a container. So I just call it container, which is gonna be a list, and we're gonna mark all those initialize all the elements inside the list to be true, and the size is going to be n. We're also going to preset the first element and the second element inside the container to be false. Container 0 and container 1 equal to false. Alright, great. So now let's move on to our for loop. We probably need 2 for loops, and the first one, we're gonna start from 2 and end at n. The reason why is 2 because, as we mentioned earlier, that we're gonna have 2 edge cases, either 0 and 1. They're not prime numbers, so we just simply start at 2. Okay, so and now what we're gonna do next is to check if the container, the element at the index I, to see if it's false or true. If it's false, which means like everything before that could be already marked false, right? And so what we're gonna do is gonna continue, and instead of writing continue, here we could just do what we want to do with the true values, right? So here if the container at index I, the value at index I is true, we're gonna do another for loop, and the range is gonna be I multiply I, and I will let you know why later. And we're gonna move at I steps, and yes. Then what we're gonna do here is to set all the numbers that we'll encounter to be false. Okay. After nested for loops, we could just simply return the sum of the container. And it's gonna sum up all the true values as ones, right? And we could get a number to be returned. Let me run the code to see if we could pass the test. It looks very potential to me, pretty positive. And great. Okay. Now let's look at what we're doing here inside the for loops. Remember, we mentioned earlier, like if this is a true value inside the list and the elements, if it's true, and then what we're gonna do is to mark all those, like the multiples of the number, to be false. Here, let's look at example. And I did too much talking, and this is what I mean. By the way, this algorithm is called is created by this person. Sieve Eratosthenes. Yeah, I'm not sure if I pronounce it right, but anyway, so here, let me refresh the page. We will see, so for every number, see we start with 2, right? For every number that can be added to 2, like 2, 4, 6, 8, 10, all those numbers are not going to be prime numbers. That's what we did here. We just mark all those numbers like multiples of the target number to be false. And yeah, once we get to the end here and we move to the next index, which is going to be 3, and we just repeat the process until we could mark all those multiples of the numbers as false all the way up to the final range. Okay, let's go back to the code. And for the time complexity, in this case, is O n log n. Let me type it out. It's gonna be O, sorry, and log n. Yeah, I know it looks kind of crazy, but that's what it is. All right, see you next time.